Hi guys, welcome back to my channel. This is Dedicator here. I'm a fourth year medical student, and so in this video we're going to be treating JAMB 2026 physics questions. Okay, just like I have promised, I said I'm going to be dropping 100 JAMB questions, but for physics. The first video I dropped was for chemistry. If you have not watched that one, do well to check it out. Okay, so this particular video is a combination of both the questions that were done on the first day of UTME and the second day of UTME 2026. So this video here, you are going to be seeing questions that came out in UTME the first day and the second day. Alright, so please do have to take note of this question because most likely the question can still come out for you luckily. Okay, so this video is just to give you a glimpse of how JAMB 2026 will look like. Okay, so if you have not written your examination, then do not take this video for granted. Okay, so let's dive into the video. The first question, the commercial unit of electrical energy is dash. The commercial unit of electrical energy. This question is a very simple one. The answer is kilowatts per hour. Kilowatts per hour. So electrical energy used in homes, okay, your prepaid meter you use at home is measured in kilowatts per hour. Alright, because it represents power, alright, times the time. That's the energy, power times the time. So the power is in kilowatts and then the time is in hour. Alright, so this is how they charge. Alright, for those of you who use prepaid meter in your house, this is how they charge kilowatts per hour. Right, that is how they set their bills. Okay, so just take note of this question. Alright, question 2. Total internal reflection of light occurs when total internal reflection of light occurs. Now, if you take note of this question, the reason why total internal reflection occurs is when light travels from a denser to a less dense medium, the angle of incidence exceeds critical angle. Just take note of that. When light travels, let me say this is a denser medium to a less denser medium, something happens. What happens is that the angle of incidence is greater than the critical angle or exceeds the critical angle. So just take note of that. So now the first option here says light travels from a rare to a denser medium. This is wrong because it's the opposite, because light travels from denser to what? To less denser or rare medium. Right? The next one, the angle of incidence is less than the critical angle. This is wrong because the angle of incidence is greater, it exceeds the critical angle. So option C says the angle of incidence is greater than the critical angle. This is definitely the correct answer. So option C is the correct answer. You have the angle of incidence is greater than the critical angle. So please take note of this in case you come across this question in your examination. So like I said earlier, this video is just to give you a glimpse of how your UTM is going to look like, especially for those who have not written their exam yet. So all the questions you'll be seeing here, ensure you take note of them. Right, so that when you come across them, you'll be able to attempt them very well. And now one thing you should take note about is all these questions are not new questions. Okay, so it is very possible that you get there that day and the question is not going to be changed, but rather it's going to be paraphrased. So all the questions that we'll be doing in this video, ensure you understand the depth of the question, understand all the explanation I'm going to be giving, because most likely if they want to repeat the question, they might not repeat it word for word. Okay, but then some persons will see some of the questions we're going to do in this video word for word. But then if you don't see it word for word, you see that some questions will be paraphrased. So it is very necessary for you to understand the depth of the question and the answer. Right? Next question: the molecules of mercury have strong cohesive forces because, right, this one is a very common question. The molecule of mercury have strong cohesive forces. It is because they have a high surface tension. They have high surface tension. So what happens is that you can have a jar like this. You can have another jar like this. So this jar contains water, and then this jar contains mercury. All right. So let me say this is for water and this is for mercury. Now, if you turn all the water away from this jar, there will be a sign, there will be an evidence that, oh, there was water once in this jar, because if you look at the surface, the inner surface of the jar, you see droplets of water. Okay, this is because the cohesive force of water is not so strong, but that of mercury, if you put mercury in a container and then you pour mercury out of that container, there will be no evidence that mercury was once there, because all the molecules of mercury, they stick together, they combine, they have a very strong cohesive force. And now the reason for their strong cohesive force, it is because they have a very high surface tension, or rather when they have a strong cohesive force, it will lead to a high surface tension. So mercury and water, mercury has a higher surface tension compared to water. Right, so please take note of that. The next question: we have friction between two surfaces can be increased by. Now you know that friction can be reduced and then friction can be increased. Right, so when you get friction can be reduced, friction can be increased, you should be careful to read your question very well, because this year's JAMB UTME 2026, JAMB is really testing how well you can read a question patiently and then understand the question. So don't just see friction and then you just run. You don't bother to read the question, because most likely what you have read on that friction, if you don't take time to read this question very well, you will end up picking lubricating the surface, right? Because in a way it is related to the friction that you see in your textbook, reduction of the friction, right? So, but now the question does not say reduction of friction. The question says an increase. What will increase friction between two surfaces? Okay, so the correct answer is roughening the surfaces. Roughening the surfaces. So rough surfaces increase interlocking between surfaces, thereby it will not increase the friction. Okay, so you should take note of that. So question 5: the instrument used to measure atmospheric pressure is known as barometer. Right. So one of the questions you most likely come across in your UTME 2026 is um parameters and the instruments used to measure them. So you should take note of thermometer. What is thermometer used for? What is hygrometer used for? What is manometer used for? You should know thermometer, temperature, hygrometer, relative humidity. Alright, take note of all these things because you most likely come across them. Alright, other instruments in physics, other instruments like ammeter, galvanometer, all those things, take note of what they measure. Alright, so now moving on. Sound waves travel faster in. Sound wave travels faster in. Correct answer is solid. Sound wave travel faster in solid. Take note. Particles are closest in solid. So one thing you take note is that in a solid, so let me say this is a solid, and let me say this is a liquid, right? So let me draw three medium. So this is solid, this is liquid, and then this is gas, right? So this is just an analogy, okay? So in gas, you see that the molecules, they are far apart. They are far apart. They're just moving randomly. In liquid, you will see that in a way they have this kind of closeness. They have this kind of closeness, right? I'm not going to draw everything, all right? I'm just giving a particular part to explain what I'm saying. So I'm not going to draw everything just because of time. Okay. So now, if you look at solid, you see that solid, they are closely and in fact tightly packed. If you look at it, you see that the molecules, it looks like it's forming one solid, one particular component. But if you zoom in, you see that they are just consist of they just consist of particles that are tightly held together. So something happens that because of the particles that are tightly held together, sound vibrations are traveled faster. That is why when sound pass through solid, it will go faster rather than in liquid or in gas. So please take note of this. Now, if this question wants to be paraphrased, what will they say? They'll tell you sound waves travel slower in what? You should know what it will be. Okay, so let's move on. The pitch of sound. This is also very, very, very important. The pitch of sound depends mainly on its take note, depends on its frequency. Alright, depends on its frequency. So when you hear frequency and it's related to sound, just know that what they are talking about is the pitch of the sound. So the pitch of the sound is determined by the frequency. These questions can still be paraphrased to tell you frequency of a sound wave determines what you know it is the pitch. Okay, so it's more like we're saying the higher the frequency, the higher the pitch. Okay, you should know what loudness means, you should know what amplitude determines, you should know what waveform determines also. Okay, very important. All right, so the next question: in a parallel plate capacitor, the capacitance will increase if it's a very simple question. All right, so now take note when you see a parallel plate, right? You know you have your parallel and then you have your series. But then let's not go too far. Now, distance, option A says distance between the plates will increase. Option B says area of the plates will decrease. Option C says distance between the plates decreases and the electric material is removed. The correct answer is distance between the plates increases. Alright. The reason is because for capacitance, reducing distance increases the capacitance. So if the distance is reduced, the capacitance in turn will be increased. Okay, so take note, when the distance is reduced, capacitance is increased. All right, take note of that. Now the next question, we have Faraday's constant, which represents the charge of 1 mole of electrons, is approximately, this is a very common question. If you know your electrolysis very well, both in chemistry and physics, then you are good to go. Right, so we have 96,500 coulombs, option A. Okay, so now the next question, for an artificial satellite to orbit the Earth, its velocity must be, for an artificial satellite to orbit the Earth, velocity must be. Now, let's start with option D, exactly the speed of light. No, this is absolutely wrong. 0, no. Greater than escape velocity. No, if it is greater than escape velocity, then it is not going to be able to orbit around the Earth. Option A says less than escape velocity but greater than the orbital velocity. This is the correct answer. Less than escape velocity but greater than the orbital velocity. Okay, so for an artificial satellite to be able to orbit around the Earth, something must happen. The orbital velocity must be greater, right? But now the escape velocity must be lesser. so that it is going to be able to orbit around the earth. Okay. Question 11. The commercial unit of energy, kilowatts per hour. We already acknowledged that in the first question. The second question, I think so. Kilowatts per hour is equal to what? Is equal to what? So now this question is just trying to tell us that the energy now, So for a kilowatts per hour usage, what amount of energy is consumed? Okay, this is very, very simple and straightforward. Just know that you have 1 kilowatt per hour. 1 kilowatt per hour, right, is equals to 100 watts, right? Hope you know 1 kilometer is 100 watts. You have 100 watts times, and you know 1 hour in seconds is 36,600, which is also 3,600, right? So now by the time we do this, we have this is going to give us about 3.6 million. 3.6 million joules. Remember, it's energy, so joules. 3.6 million joules. Now let's look at the question. First question says that 3600 kilojoules, 1000 kilojoules, 3600 joules, 1 joule. Alright, if you look at this, these joules can be converted to kilojoules, right? By the time we divide by 1000, so if we divide by 1000, we're eliminating 3 zeros, right? So we have 3600 kilojoules. So the commercial unit of energy is 3600 kilojoules. Remember, the reason why we got 3600 kilojoules is because the standard unit or the standard billing for commercial unit of electricity or usage of electricity is kilowatts per hour. But now, when we want to look at the energy, what we are going to do is to multiply the 1000 watts times the 3600 seconds, and then we're going to get the answer. Okay, so question 12. A 10 kg weight is on a 45, is on a 45 incline. If G is equal to 10 meter per second square, what is the component of the weight acting down the slope? Acting down the slope. If we were to represent this in diagram, we'll have something like this, right? We'll have something like this. And then we have something going down like this. This is what is. So we have 45 degree, that is the angle. So we have theta is equal to what? 45 degree. Take note of that. 45 degree. And then we already know gravity. Acceleration due to gravity is always 10 or 9.8, depending on what you are given in the question. Alright, and we already know the weight of this guy is what? 10 kg. Right? 10 kg. All we need to do is to solve. Now, how do we get the component of the weight acting down the slope? Okay, is it horizontal component or is it vertical component? All right, you will now see that by the time you get that, the formula we are going to be using is mg sine theta. Right, you know we have mg sine theta and we have mg cos theta. It is depending on the component. The component will determine which one you are going to be using. Right, so since this is down component down slope, we're going to be using mg sine theta. So what is m? M is 10, right? So we have 10 times 10, right? Sine 45 degree. All right, so 10 times 10 is equals to 100. So we have 100 sine 45 degree. 100 sine 45 degree. Now, you should take note of this. You might want to wonder, and then you ask yourself, how do I do sine 45? Take note that when you get to the examination, your UTM, the calculator that I've given to you, you are not going to be able to perform any trig function. So what this means is that you should know standard trig in your head. Standard trig should be in your head. 45 degree, 30 degree, 60 degree, 90 degree. Those 4 angles. You should know the sine, the cos, and the tan for these angles. Because most likely, if JAMB wants to give you any trig, it's not almost likely. If they want to give you any trig, they'll give you standard trigs. Because they know that there's no way you'll be able to calculate trig without a 4-figure table or a calculator. But then you can when you are giving the standard. So sometimes you might be giving the standard in your question, or you might not be giving the standard. If you look at this question, they don't give us standard, and there's no way we will solve this thing without knowing the standard or the answer, sine 45 degree. All right. So if you know your standard very well, you know that sine 45 degree is equals to 1 over root 2. 1 over root 2. So we have 1 over root 2 times 100. All right. So we have 1 over root 2 times 100, and so this is going to give us. So let me do it here. We have 100 root 2. This is our answer. Now take a look at the option. Is anything like 100 over root 2? No. Please take notes. That is why you must be very, very calm. You must be very, very calm. Like I said earlier, that UTME 2026, they will be testing your patience. Now, somebody will just get 100 root 2 and immediately rush to go and pick option D because option D is looking like it. but then you'll be so wrong. Okay, so now take note of this. When you have 100 root 2, there's what we call rationalization. Rationalization in mathematics when you are dealing with sort, right? So when you rationalize, you multiply this guy by root 2 over root 2. I hope you guys still remember this mathematics. Root 2 over root 2. So root 2 over root 2, you now have 100 root 2, right? You have 100 root 2 divided by root 2 times root 2. You already know root 2 times root 2 is 2, right? So now 2 here 1 and then 2 here 50. You can see we have an answer that is in the option. So we have 50 root 2 as our answer. So correct answer is 50 root 2. Okay, so when you are solving trig function question, you should be very, very, very careful. Okay, so that you don't get it wrong. All right, question 13. Which of the following is the correct unit for measuring luminous intensity? Correct answer is candela. Candela is the SI unit for luminous intensity. You know, ampere is current, Kelvin temperature, mole is the substance, okay, amount of the substance. Please take note of all these things. You should know your quantities. You should know fundamental quantities. You should know derived quantities. You should know their dimensions. Okay, and most importantly, their SI units. It's very, very important. Question 14. An object is placed at the center of curvature of a concave mirror. The image formed is, now there's something you take note of about concave mirror and convex mirror. Lenses is something that you will hardly escape in physics questions. So if you master lens very well, then you are sure of attempting and getting about 3 to 5 questions in your physics UTME. Okay, now when you hear center of curvature for concave and for concave mirror at the center of curvature, the image forms at the same point. Please take notes. The image forms at the same point. It will give the same size, it will be real, and then it will be inverted for a concave mirror. It will form at the same point, it will have the same size, it will be real, and then it will be inverted. So if you look at this, which of the options fits this? You see that it's option C. All right, option C. Now, this question wants to be paraphrased. It will just tell you an object is placed at the center of the curvature of a particular mirror. The image formed was real, inverted, so it's the same size as the object. What kind of mirror is that? You know it is concave. Okay, it's also important that you know for convex. Convex is the opposite of concave. So once you know for concave, you will know for convex as well. All right, so question 15. You have, according to Boyle's law, the volume of a fixed gas of mass is inversely proportional to its pressure, provided that you take note that when it comes to relationship with gases, there are 3 quantities. You have pressure, you have volume, and then you have temperature. If 2 exist, the other one is going to be constant. So now the question says that volume exists, right? So volume exists. Then we have pressure also exists. So volume and pressure exists, which means that what is constant is what? The temperature. So we'll just look for the option that has temperature is constant, and that is option B. Temperature remains constant. Okay. Question 16. A representative value for the speed of sound in air at STPs is dash. Now look at this speed of sound. Like I said, JAMB is going to be testing your patience, and it is very, very important for you to read your questions and understand it very, very well. Don't be in haste. Now, once somebody says speed, there's every possibility that the person will just run to 3 times 10 raised to 8 meter per second, because this is the speed of light. But the question says speed of sound. Right, so for speed of sound, the answer is 330, approximately 330 meters per second. You can see how tricky these people are. Right, so please take note of that. Then the next question: the phenomenon where a wave changes direction as it passes from one medium to another is known as refraction. Okay, when it changes direction, once you hear change in direction from one medium to another, it is known as refraction. So refraction occurs due to the change in speed of wave in different medium. Right, so by the time the speed is changing in different medium, that phenomenon is known as what? Refraction. Okay, question 18. Which of the following gas laws is represented by the equation PV equals to nRT? This is a very simple question and there's no need for too much explanation. The answer is the ideal gas law. Okay, the ideal gas law. You already know it's not Boyle's law, because Boyle's law is PV and Charles' law is V over T. Right? You already know that Charles' law is V over T. Graham's law for diffusion, you should know that one also. But this guy is giving us a relationship between pressure, volume, number of moles, temperature. It is the ideal gas law. Okay, so the ideal gas law is a combination of Boyle's law. Now, this question can be paraphrased to tell you ideal gas law is a combination of how many laws? It's a combination of Boyle's law, it's a combination of Charles' law, and it's a combination of Avogadro's law. So 3 laws into one equation gives you the ideal gas law. Right? So question 19. In optics, the reciprocal of the focal length of a length is called its dash. Okay, this is a very, very sweet question. Now, you come across question like this, they will tell you, calculate the power of this length. When you see a question like that, say calculate the power of this length. Calculation of power of length is equals to 1 over the focal length. So they'll give the focal length, they'll tell me the focal length is 5, focal length is 4, focal length is 10, focal length is 25, and they'll tell you calculate the power. So let me say the focal length is 25. So we have 1 over 25, right? So 1 over 25, that should give us approximately 0.04. If I am correct, 0.04 D. This is how the power of the length is represented. Okay, this is just to give an example. All right. So if you go back to the question, optics, the reciprocal of a focal length. You know, reciprocal is 1 over something. You should know that from basic mathematics. When you hear reciprocal, the reciprocal is 1 over something. So the reciprocal of the focal length of a length is known as the power of the length. The power of the length. That is option B. The power of the length, and the power is in meters, measured in diopters. Diopters. So this D that you are seeing here is known as diopters. Next question. The energy stored in a stretched spring is known as, so this is elasticity, right? So when you hear anything stretched, spring, in force constant, stretched, spring, when you hear that in physics, what should come to your mind is elasticity, right? Elasticity. You see some stuff like this, and you just do something like this, 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 and give you something like this. To tell you, just when you see things like this, what should come to your mind is elasticity. Okay, so the energy stored in a stretched spring, you already know what should come to your mind, elasticity, right? So kinetic energy, no. Chemical energy, no, can never be correct. Gravitational potential energy, no. Elastic potential energy, absolutely correct. So the energy stored in a stretched spring is known as the elastic potential energy. Okay, 21. During the electrolysis of copper 2 sulfate using copper electrode, the process at the anode is the process at the anode. You should know what happens at the anode, you should know what happens at the cathode. You have reduction, you have oxidation. Now I explained all of this process, all of these things, everything relating to electrolysis in the video I made for chemistry. So please do well to check out that video. If you are watching this video and you have not written your UTME, and then you have not also checked out the chemistry video, please try as much as possible to check out the chemistry video. This period, a lot of updates is going to be dropping on my channel, right, as regards your UTME examination. So if you are watching this video and you have not subscribed to my channel, please do well to hit the subscribe button so that when videos like this drop, you are going to be among the first set of people to get a notification. Okay, ensure you subscribe, because if you don't subscribe, you might not see this video again except you search for it. All right, I am also going to be dropping for biology. All right, I'm still compiling the questions for day 1 and also the questions for day 2. I'm getting some questions, but then it is not up to 100. I'm still looking for a way to make it up to 100. And as soon as I get it up to 100, I'm going to drop the video. So if you are watching this physics and then you're also going to be writing biology and you're interested in that video, please do go to drop it in the comment section. From the day this video is going to be dropped, the biology is going to be dropped 24 hours after this physics has been dropped. But if I see that a lot of persons are demanding for the biology, I will drop it in less than 24 hours. Okay, so now let's continue with the question. All right. During the electrolysis of copper 2 sulfate using copper electrons, the process at the anode is the copper ions or the copper atom dissolve into the solution. All right, formation of copper ions, so it will dissolve into the solution. 22. An object starts from rest and accelerates at 2 meter per second. Accelerate at 2 meter per second. What is its velocity after 5 seconds? You take note, these questions are the most sweetest question you can ever come across in physics. Once you see acceleration, velocity, distance, and stuff like that, you should know Newton's equation. You should know Newton's equation. You know the first equation, second equation, and then the third equation. So from your question, you will now know if you are using the first equation, if you are using the second equation, or then you are making use of the third equation. So now let's take a look at this question. The question they gave us acceleration, right? Acceleration. That is A. So A is equals to 2, right? A is equals to 2. They give us velocity, initial velocity. But now the initial velocity is going to be 0 because they said the object started at rest. So they give us initial velocity as u is equals to what? 0. Now what's the question? The question is what is the velocity after 5 seconds? So they give us time. Time is equals to 5. So what is the velocity? What is the new velocity? That's going to be what? V. Now if you take note of this question, you see that this question is connecting the first equation, which is V is equals to u plus 80. Remember this equation, right? It's very, very important. Okay, you should know the second equation, you should know the third equation. The derivative is not so important now because the examination you are writing or the examination you are preparing for, nobody's going to ask you for derivative. So to be an O-level examination like your WAEC, your NECO, your GCE, and you can learn the derivative. But for now, All you just need to do is to memorize all of these formulas. Okay, so now if we do all of this, we have u is equal to 0 plus a is 2. 2 times 5, you have 10. Then v gives us 10 meter per second. You can see it's as simple as anything you can imagine. Alright, 23. Which of the following colors of light has the longest wavelength? Which of the following colors of light has the longest wavelength? Now, there's something that you should take note of. There is a mnemonic, you must have heard of it before, or you must have seen it. We call it the VIB or the vibe GOI. The vibe GOI. The vibe GOI. Now, this vibe GOI is increasing wavelengths. We have the vibe GOI, and then we also have another one. Okay. Alright, so this vibe gear, you have V to be violet, I to be indigo, B to be blue, G to be green, Y is yellow, O orange, and R is red. And this is in increasing order of wavelength. Okay, so now you have this mnemonic. What do you think will be the highest or the longest wavelength? You have red, because this is where red is. Red has the highest wavelength. Okay, next question. The fundamental frequency of a plucked string is 200 hertz. 200 hertz. The frequency of the third harmonic is, you should know the formula for third harmonic. Third harmonic is equals to 3 times fundamental frequency. Alright, and they have given us the fundamental frequency already. So the fundamental frequency is 200. So you don't need to stress yourself too much. Third harmonic is 3 times the fundamental frequency, and 3 times 200 gives us 600. It's as simple as that. Next question, 25. A device that converts mechanical energy into electrical energy is known as a dynamo. Okay, it's either you will see dynamo that day, or you will see generator, or you can even see both of them the way it is written here, like this. Okay, so a generator converts mechanical energy into electrical energy via electromagnetic induction. Okay, so you should take note of that. Now, question 26. The temperature at which the water vapor present in the air is just sufficient to saturate it is known as. Correct answer to this question is dew point. Please take note of that. Dew point. So the dew point is the temperature at which air becomes saturated. Alright, once the air becomes saturated, condensation will now begin. That's why you see dew. Okay, condensation will now begin because the air is now saturated. That point is known as the dew point. Okay, 27. Which of the following is a vector quantity? So you preparing for UTME 2026 and you be doing physics, please take note. Vector quantities, scalar quantities, they are very, very important. You should know the difference, direction and magnitude. Magnitude only. Okay, you should know the quantities that fall under vector, you should know the quantities that fall under scalar. Right, now if you look at this, which of the following is a vector quantity? Displacement is a vector quantity, because displacement has to do with direction. Okay, that's the difference between distance and displacement. Distance, you just go, there's no direction. But in displacement, there's direction. We tell you north, south, east, west, there's a direction. Okay, that is why it is a vector quantity. All right, so moving on, we have the next question. The process of adding impurities to a semiconductor to increase its conductivity is known as doping. Please take note of that. It's known as doping. It's a very common question. Doping. Right. So doping introduces charge carriers, okay, like electrons or holes into semiconductors. What? Why are they doing that? To increase the conductivity of the semiconductor. Okay. Next question. We have the convex mirror is most likely used as a driving mirror, because this is a very common question that comes out. Okay, the mirror that you have in your vehicles, they are convex mirror. Okay, so they can paraphrase the question like that. Tell you, mirrors in vehicles are what? They are convex mirror. So why is it that they are convex mirror? Okay, so convex mirror gives a wider view of view. It gives a wider field of view, and then it helps the driver to see more. Convex mirrors, they help the driver to see more. Okay, so now option C says provides a wide field of view. This is the correct answer. That is why convex mirror is used. Okay, the next question. The unit of magnetic flux density is Tesla. All right, so Tesla is the SI unit for magnetic flux density. Question 31. When a net force acts on an object, the object accelerates in the direction of the force. Accelerates in direction of the force. This is Newton's dash. Newton's dash. You should take note. You should know Newton's first law. You should know Newton's second law. You should know Newton's third law. Alright, and you should also know Newton's law of gravitation. Now, you should know the first law, which talks about inertia, and you should know the second law, where the formula now comes in. So the second law brings the formula, and that formula is what? Mass times acceleration. This is for the second law. And now this question connects something. This question connects something. What does the question connect? It connects force to what? Acceleration, right? So force and acceleration. We already have force and acceleration. Sit here, force here, and then we have acceleration here. So definitely this law is talking about the second law of Newton. Alright. Question 32. The apparent change in frequency of a wave due to the relative motion between the source and the observer is known as the Doppler effect. Take note, it's known as the Doppler effect. Okay, so the frequency appears higher or lower due to the motion between the source and the observer. So the source, is the source moving? Is the source in motion? Is the observer also in motion? If the observer is in motion, if the source is in motion, the frequency tends to either be higher or tends to either be lower. The effect, or what this phenomenon is called, is the Doppler effect. Okay, please take note of that. All right, so the next question: an electric ion is rated 1000 watts and 240 volts. The resistance of the element is the resistance of the element. This question is a very, very, very simple question. Okay, so when you see watts, you already know it's power, right? You already know it's power. And when you see volts, you already know it is voltage, right? And then you see ohms. You see ohms, ohms, ohms. Once you see ohms, you already know you have resistance. And now, so the next question is, what is connecting power with voltage and then with resistance? That's the next question you should ask yourself, because when you come across questions like this, it is not just enough for you to just pick a formula and then you just start solving. The reason for you picking a formula should be based on the parameter that you are given. So it is the parameter that you are given that will tell you, oh, this is the formula that I am going to use. So now if you look at this, the parameter that was given here, what connects power with voltage and resistance? I hope you still remember this formula. P is equals to V square over R. You still remember this formula, right? This is the formula we are going to use, because we have P, we have V, and we have R in the question. So this is the formula we are going to use. So by the time you find subject of formula, you have R is equals to V square over P, right? V square over P. So now what's V square? V square is 240 square, 240 square. So you have 240 square divided by P. What's P? P is 1000. Okay, the square, let me put the square. 240 square. So by the time you do this and solve all of this very well, you are going to get 57.6 ohms as the resistance for this electric ion. Okay, 34. Which type of radiation has the highest penetrating power? Gamma rays. This is a very common question that you will see. So this particular information I want to give you now is for those who still have their examination far. Like you still have your examination 3 days time from the point you're watching this video, or in 4 days time from the point you're watching this video. I've made summaries of important topics that you most likely see for your UTME in all the science subjects. So if you're interested, please do well to indicate in the comment section. And I'm going to give you a link that you're going to use to access those documents. Okay, so if you have watched this point, please don't forget to hit the subscribe button. Right, so question 35. A hydraulic press works on the principle of Pascal's law. Works on the principles of Pascal's law. So Pascal's law states that the pressure applied to a fluid is transmitted equally in all directions. Okay, hydraulic press, Pascal's law. 36. A body moves along a circular path with a constant speed. Its acceleration is directed towards the center of its path. Alright, directed towards the center of its path. So a body, this is a body, right, moves with a constant speed in a circle. It continues like this, and it's just moving, just moving, just moving. The speed is constant. Something happens, the acceleration will be directed towards the center of its path. Okay, even though the speed is constant, direction will keep changing. So there is centripetal acceleration acting towards the center. So this idea is centripetal acceleration. 37. The property of a liquid that makes it behave like a stretched elastic skin is its surface tension. Okay, surface tension. So they'll tell you, why is it that water comes in drop? Water forms something like this before water drops to form something like this. Okay, it is as a result of its surface tension. So surface tension means the surface of a liquid acts like a stretched elastic membrane. Okay, so you see water sometimes it looks like as if it's stretching, as if it stretches. It's because of the surface tension of the water. 38. When a person jumps out of a boat onto a pier, the boat moves backward. This illustrates the Newton's third law. Now, why is it Newton's third law? Remember, Newton's first law is inertia. Newton's second law is talking about force. Newton's third law talk about the action and reaction, right? Where action and reaction is equal and opposite. So if you are pushing the boat backward, the person jumps forward. You can see, so the person is jumping forward, boat is going backward. So you can see the action is opposite and is equal. The reaction is opposite and is equal. So you can see that. So it explains Newton's third law. 39. The quantity of heat required to change a unit mass of solid to liquid at constant temperature. When you see solid to liquid, something should come to your mind. Solid to liquid, is it melting, vaporization, stuff? Solid to liquid is melting, right? And melting is also, when you see melting, what comes to your mind first? It should be fusion. So latent heat of fusion is the answer. So what is latent heat of vaporization? So if you see that this definition, they change it. They now change solid to liquid to gas. The answer is going to move from latent heat of fusion to latent heat of vaporization. Okay. Question 40. Which of the following is an example of a longitudinal wave? So longitudinal wave, sound wave. Wherever you see sound wave, you know that wave is a longitudinal wave. The rest of these waves are transverse waves. Okay, 41. The relationship between the velocity, frequency, and wavelength of a wave is represented as. Please, when you see a question like this, like I said, patience. Ensure, because sometimes simple questions can over incite somebody and then you end up picking the wrong answer as a result of rushing. Okay, so when you say a question like this, someone will be like, oh, I know wave, I know the formula. Now, if you take a look at this properly, option A, B, C, D, you see that it's as if all of them have this kind of similar look somehow. It's only when you now calm down to look at it, you now know that, oh, these things are not the same, actually. Okay, so if you look at it, option B is the standard wave equation, which says that the velocity is equals to the frequency times the wavelength. Okay. Question 42. An example of scalar quantity is distance. We talked about it the last time. Distance does not have direction. Distance, you just be going straight. They tell you go like this, go like this. There's no direction. You are just going in meters. There's no direction. But when it is displacement, that's the direction. So distance just has only magnitude. Okay, that's only magnitude. Just tell you 40 meters, 30 meters. There's no direction. So you don't know where you are going 30 meters. So if someone just comes to you and say from your house, walk 30 meters, you'll be seeing 30 meters where? 30 meters front, back, side, up, just like that. So there's no direction. Okay. So 43. The work done in moving a charge of 5 coulombs through a potential difference of 12 volts is. This is also a very simple question. You should know that work, all right, work is equals to charge times voltage. Work is equals to charge times voltage. All right, charge times voltage. So this formula is a very simple one. So if we find the subject of formula, find the parameters, we have that the work is equals to charge, right? That's 5 times what's the voltage? We have 12. That is going to give us what? 60 joules, right? Question 44. Which of the following instruments is used to compare the relative density of liquid? Okay, I've answered this question in one of the questions relating to barometer, measurement of pressure. The answer is hygrometer. Hygrometer is used to measure the relative density. Sorry, not hygrometer, hydrometer. Okay, hydrometer. So please take note. This is what I meant by you must be very, very patient. You can see now I'm not patient. I went to pick hygrometer because my brain now has marked relative humidity. Relative humidity. So when I say relative humidity, I know it is hygrometer. So this time I now change it to relative density. So you can see you have to be very, very patient and observant. So you don't pick the wrong answer even for a question that you know. Okay, so the answer is A, hydrometer. Hydrometer is used to measure relative density of liquid. Alright, question 45. The change in the direction of the wave front when it passes an obstacle is known as diffraction. 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 So diffraction is the bending of waves along obstacles or opponents. You should take note of that. 46. A stone is dropped from a height 20 meters. How long does it take to reach the ground? How long does it take to reach the ground? So you have, let's look for what we're giving the parameter before we know what we are solving. That is what you do first. So we have height 20 meter. So height, you give us height 20 meter. That's h 20 meter. 20 meter. All right. Height 20 meter. How long does it take? That's the time. T. T. That's what we're looking for, right? And then we have acceleration due to gravity. A is equals to 10, right? So we have 20. Now, the next thing is which formula connects this. Remember when I said this earlier that when you see a question like this, what should come to your mind is Newton equation. Now, if you look at the Newton equation, the first one is V equals to U plus AT. Well, we can say we want to use that, but then we are not giving any velocity. And we are not told to look for velocity. So that one is out of the option. So now, the second one is S is equals to UT plus half AT square, right? Half AT square. Now, you should take note that the Newton's law of motion can be rephrased, or will I say paraphrased, when it involves dropping of objects. You know, we have the equation that connects objects moving in a plane from one position to another, like a car moving, a boy running, just like that. Then we have another equation for the same equation, but rather it is paraphrased when we have objects dropping. You should know that S is equals to H. Please take note. S is equals to H. Then A will be equals to what? G. You remember this change, right? Remember this change. So we can actually see if we can use this formula. So S is now going to be H. There's no initial velocity, so this automatically strikes out. So we have half AT squared. So it's now equal to H is equals to half GT squared, right? Half GT squared. Then I think we can solve from here. We can solve from here. So H, they give us H. H is what? H is 20 meter. 20 is equal to half times 10. Remember G is 10. Half times 10, that is what? 5, right? So we have 5t squared. 5t squared. To make t squared the subject of the formula, we divide by 5, right? And divide by 5. So we have 4. So we have t squared is equals to 4. This makes what? T equals to 2. You can see, if you are not patient enough, once you just arrive at t squared is equals to 4, there's every tendency that you rush and go and pick 4 as the answer. But please, don't be tempted. Ensure you solve till the last point. Okay? Alright. The next question we have: the point in a body where its whole weight appears to act is the center of gravity. This is very, very simple. Center of gravity. So the next question: which of the following mirror is used by dentists to see a magnified image of the tooth? Correct answer is concave mirror. Concave mirror. So concave mirrors produce magnified image when the object is within the focal length. Okay, you should take note of that. What is the SI unit of work and energy? Okay, the SI unit of work and energy. We have solved questions relating to work. We have also solved questions relating to energy. If you can remember, we solved a question relating to work where we did charge times voltage, right? And then we solved for energy when we used kilowatts per hour. You still remember, right? So the SI unit for work and energy is joule, because that was what we finally arrived at. 50. An object is placed 10 centimeter in front of the convex lens of focal length 15. The object form is virtual and magnified. Now, how did I know that the object form is virtual and then magnified? It is because, number one, when the object distance is less than the focal length, object distance is what? 10. Focal length is what? 15. Alright, the image is going to be virtual. It is going to be upright, erect, and magnified. That is one of the length rules. So we have length rules. Length rules. It's very important that you know some of these length rules. When the object distance is greater than the focal length, you should know what is going to happen. When the object distance is equal to the focal length, you should know what is also going to happen. Okay, question 51. A device used to step up or step down alternating currents. Remember, this one is very, very simple. We have what is called step up and step down. Step up and step down what? Step up and step down transformer. So the answer is transformer. So a transformer changes AC voltage levels using electromagnetic induction. So they might ask a question to tell you the principle that a transformer works on or works with is what? Electromagnetic induction. Okay, the velocity of light. Okay, you can see now. Remember the first one was speed of sound. Now we have velocity of light. Take note, if they say velocity, if they say speed, they are still talking about the same thing because it has the same SI unit, right? That's the same unit, meter per second. In a vacuum, is approximately what? It's approximately 3 times 10 raised to power 8 meter per second. Alright. 53. Which of the following instruments is used to measure the current flowing through a circuit? Okay, remember I said you should know instruments and what to measure. When you hear current, what should come to your mind is ammeter. Ammeter is used to measure current. Alright. An ammeter measures electric current directly in amperes. Okay. 54. The process by which heat is transferred through a vacuum is radiation. You should never forget this. It's a very common question. Once you see vacuum, just know it is radiation. Okay, radiation does not require a medium. So when you see a question relating to vacuum, know that a medium is not there. Okay, a medium is not required. Okay, so it can only occur through a vacuum. All right, so please take note of that. Question 55. A transverse wave is one in which the particles of the medium vibrate. Alright, the particles of the medium vibrate. What is a transverse wave? A transverse wave is one in which the particles of the medium vibrate. Is it parallel to the direction? No, it is perpendicular to the direction. That's the difference between transverse and longitudinal. It's perpendicular to the direction. So in transverse waves, particle motion is perpendicular to the wave direction. Alright, you should take note of that. Question 56. The escape velocity of a projectile from the earth depends on the escape velocity. You should know the formula for escape velocity. So the escape velocity depends on the gravitational field, and gravitational field depends on something, depends on earth mass and the radius. That's the earth, the mass of the earth, and then the radius of the earth. Take note, it does not have anything to do with the object's mass. That's the object that is escaping, or the object that is experiencing the projectile. It has nothing to do with it. It is the earth's mass and then the radius. So if you look at this, you see that the correct answer is option B, because it has nothing to do with the mass of the projectile. Right? I said that. So, question 56. When two light waves of the same frequency and constant phase difference overlap, the phenomenon is known as interference. Interference. When you hear anything overlap, come together, mix, wave mixing, just know that phenomenon is known as interference. So, interference occurs when waves superpose. They superpose with a constant phase relationship. Okay, so one wave might be coming like this, and then another wave is coming like this phenomenon is known as what? Interference. Please take note of that. 58. Which of the following material is a good conductor of electricity? This question is not a question that you should fail. Okay, take note of that. 59. The power distributed in a resistor of 10 ohms carrying a current of 2 ampere. 2 ampere. You should remember, what are you giving? You have 10 ohms. So we are giving resistance, then we are giving current I. I. You should know the formula connecting power and then current and resistance, which is current square resistance. That's I square R. Okay, what is I? You have 2 square times what is the resistance? You have 10. So if you do this very well, you have 4 times 10, and then 4 times 10 is going to give you 40 watts. Okay, you should also take note, this question can be paraphrased. It will give you volts and then it will give you resistance. You should know how all of these equations can be interchanged to fit the question you are given so that you can be able to solve. Alright, question 60. The image formed by a plane mirror is always, because it is a plane mirror, it is going to be upright. Okay, so plane mirrors produce upright images. They produce the same size of images, and then they produce a virtual image. It's not the same thing. They produce a virtual image. So if you look at this, from what I said, option B is correct. So the image is virtual, it is erect or upright, and it has the same size. Okay, which of the following is the correct relationship between the Celsius and the Kelvin temperature scales? Okay, so like I said, ensure you are patient. Don't just rush. If you look at all of these, you see that they have a way of just trying to be tricky. Okay, but you should know that K is equals to Celsius and Celsius plus 273. That is option B. Okay, so now the next question we have a hydraulic jack. When you see hydraulic, once you see hydraulic, what should come to your mind is pressure, right? Hydraulic jack works on the principle that pressure applied to an enclosed fluid is transmitted equally in all directions. We talked about this before. This is known as the Pascal's law. You can see the question is paraphrased, but then it is still having the same answer. Alright, so question 63. The bending of light as it passes from air into water is due to the velocity. Okay, velocity. Velocity. So refraction, remember refraction is where you have wave changing as a result of passing through different medium. Okay, when you see one medium air, another medium water, and then as they are passing through each other, there's a bending of light. Just know that it is what your refraction. So refraction occurs because light changes speed in different direction. Okay, speed, velocity. Remember, I said when you see those two, they are talking about the same thing. 64. The unit of electrical capacitance is farad. Okay, farad. So you see something like this, F farad, or you see something like this. Okay, 65. Which of the following electromagnetic waves has the shortest wavelength? Okay, so you also come across questions like this. Electromagnetic wave. For electromagnetic wave, we also have a mnemonic for that. Okay, the mnemonic for that is a very simple one, and then you can use it to know. So what's the mnemonic? You have, where's my pen? Okay, so you have rich men, rich men in Vegas use X-ray gun. Rich men in Vegas use X-ray gun. Rich men in Vegas use X-ray gun. And now this is increasing frequency, and decreasing wavelength. So let me put it, decreasing wavelength and then increasing frequency. So what's the question? What they asked us? They said the question is, which of the following Which of the following, okay, the decreasing is meant to be this angle. It's meant to be this angle and not this other side. So this, don't look at this. So this is decreasing, and this is increasing. All right, increasing. Just take note of that. So now the question says, which of the following electromagnetic waves has the shortest wavelength? So what are we concerned with? Wavelength, right? Wavelength. So if it is decreasing, which one will have the shortest wavelength? It's definitely gamma rays. It's as simple as that. They say which of them are the highest. You should know. Now they can change the question. They will not use wavelength. They will use frequency. But you should know. So I've given two mnemonics now in this video. Rich men in Vegas use X-ray gun, and then we have the vibe gear. That one is for the colors, right? Vibe gear, and you should know it is arranged in increasing wavelength. An object of mass 5 kg moving with a velocity of 10 meters per second, its kinetic energy is. This is a very straightforward question. You already know kinetic energy is half mv square, right? So that will be half times what is m? M is 5. V is what? 10. That's 10 times 10. That's 100, right? 100. So 5 times 100, you have 500 divided by 2. So you have 500 divided by 2. 500 divided by 2 will give us 250 joules. 250 joules. 67. The force of attraction between two masses is inversely proportional to the square of the distance between them. This is the Newton's law of universal gravitation. It is very, very straightforward. What this law says is that there is a force of attraction that is proportional to what? The two masses, m1 and then m2, right? And then it is inversely proportional to something, the square of the distance, radius, r square. That's where we have this formula. Alright, then the constant, you now put the G. Remember this formula, right? That's straightforward as that. The next question, the rectangular glass block has a refractive index of 1.5. The speed of light in the glass is equal to. Alright, so refractive index, you already know that refractive index, let me say RF, is equals to the speed in vacuum. Speed in vacuum over speed in the medium. Remember, vacuum is not a medium, right? So now, the speed of light in the glass. Is glass a medium or not a medium? Take note, glass is a medium. So in all, what are we looking for? We're looking for M, right? We're looking for M. We're looking for M. Refractive index is 1.5. 1.5. V, this one in vacuum. What were we giving? Speed of light. What is speed of light? You should know speed of light, right? We have solved a question like that. 3 times 10 raised to power 8. That is the speed of light divided by glass. So we're looking for glass, right? If you do this very well and get the subject of the formula, you have your answer to be 2.0 times 10 raised to power 8. Okay, that's simple as that. 69. The period of a simple pendulum depends on its length. Okay, you should take note of that. It depends on its length. You know, period of a simple pendulum. You should remember this formula where you have 2 pi, a very common and sweet formula, 2 pi square root of L over G. And this L is what? Length. Alright, length. 70. Which of the following is used to store electrical charge? Electrical charge are stored in capacitors. Okay. All right. In the electrolysis of acidified water, the gas involved at the cathode is hydrogen. This is a very common question because they know it's tricky. Right. You know that what is meant to evolve in the cathode normally from acidified water H2O. H2O. There's a common principle that you will just say that okay, H go to one side, O goes to one side. Okay, you know that the negative is going to go to anode, positive is going to go to cathode, right? For the positive here, what you have hydrogen. Okay, so reduction occurs at the cathode. Take note, reduction occurs at the cathode, and then hydrogen ion gains electron to form hydrogen gas there. So you have hydrogen. All right. 72. The heat required to raise the temperature of a body by 1 K is its a very common question. Heat capacity. Okay, heat capacity. So heat capacity refers to the whole body, while specific heat capacity refers to per unit mass. So take note, if you look at this question now, if they say per unit mass, what you are going to pick as your answer is specific heat capacity. But they say the whole body, did not say per unit mass, it is heat capacity. Okay, 73. Which of the following is a second class lever? Alright, second class lever. You have wheelbarrow. Wheelbarrow is a second class lever. Alright, you should know in second class lever, the load is between the effort and the fulcrum. Alright, load is between effort and fulcrum, and you see that in wheelbarrow. Alright, 74. The process by which a solid changes directly into a gas. You should know this is known as sublimation. You should know this from your chemistry. Sublimation. 75. A wave that can travel through a vacuum is a electromagnetic wave. Remember, When you hear vacuum, it means that they don't need a medium, right? They don't need medium. So electromagnetic wave like light, they don't need medium. They just travel like that. Like they travel without medium. Okay. 76. The pressure of a gas is 100 pascals at a volume of 2 meter square. If the volume is reduced to 0.5 meters square at a constant temperature, the new pressure is. Now, this is a very, very simple question. It's very simple and interesting question. When you see pressure and volume, what comes to your mind? Pressure and volume. That's not Boyle's law, right? And you know, Boyle's law is inversely proportional, like inverse. Boyle's law is inverse, right? Boyle's law is inverse. Now, this is the fastest way to solve. Now, this only works for Boyle's law and Charles' law. Don't use this for combined gas law or ideal gas law. I am begging you. So you have pressure and then you have volume, right? In this question, we don't necessarily need to convert anything, right? You know, if you are giving temperature, you have to convert to Kelvin, and then just like that. But this one, we're not converting anything. So the pressure we're giving is 100. We're giving 100, right? And then we're told to find the next pressure. Let's say X. Then volume, we're giving the first volume 2, and we're told that it reduced to what? 0.5. The first question you ask yourself is, if volume is increasing, will pressure decrease or increase? Pressure will do the opposite because it is an inverse relationship. So since this one is decreasing, right, it means that there is going to be an increase. There is going to be an increase, which means that this 100 will increase. So anything less than 100, the option is not correct. So 50 is wrong, 25 is also wrong. So our answer is either 200 or 400. So how do we now get it? 2 to 0.5. What exactly happened? They divided, right? What did they divide by? If you check your calculator well, you see it was divided by 4. They divided by 4. Now, if division causes decrease, what will cause increase? Multiplication, which means that we're going to multiply this guy by 4. 100 times 4, that gives us 400. It's as simple and straightforward. This is one of the easiest ways to calculate instead of doing P1, V1. It's not like you can't do that one, but then you need to solve so smartly. Okay. All right. So next question, the unit of luminous flux is, take note, they did not say luminous intensity. Like I said, take your time to read the question. Some people just know luminous, will run to candela. Luminous flux is lumen. All right, luminous flux is lumen. So lumen measures the total light output. That's the luminous flux. That's total light output. Okay. 78. Which of the following instruments is used to determine the relative humidity? You can see that question again. Okay, so it's not the same question. First one was relative density. So relative humidity is hygrometer. Hygrometer. Alright, 79. The resistance of a wire depends on the following except you should know the formula for resistance. Resistance, then you have this guy like this, then you have length, and then you have area. Right? Length is length there, yes, length is there. Cross sectional area is also there. Right? So if you look at this, you will not see temperature and you will not see mass in the equation. But theoretically, temperature affects the resistance of a particular wire, because by the time you hit that wire, something happens to the wire. The wire is going to change in size, it's going to change the length, it's going to change the area, which in turn is going to affect the resistance. But the mass does not affect it. So mass is the correct answer. 80. An object moving with uniform velocity has an acceleration of 0. Uniform velocity. This is a very tricky question, but it's simple. Remember that acceleration is what? Change in velocity, meaning that there will need to be a change before we have what? Acceleration. If there is no change, there is no acceleration. It's as simple as that. Alright. 81. The color of light that is refracted the most when passing through a glass prism is, remember the mnemonic we have, Rib Goy. Rib Goy. Alright. So now, vibe. Sorry. Vibe Goy. So the color of light that is refracted the most when passing through a glass prism. You already know that this is increasing wavelength, right? Now, if you take note, what is going to refract more is the one that has the shortest wavelength. And what are the shortest wavelengths here? You have V, which is violet. Violet. 82. A device that converts light energy directly into electrical energy. Light energy directly into electrical energy is known as a solar cell. Okay, this one is a very simple question. Nobody should fail this. 83. The frequency of a wave with a period of 0.02 seconds is, remember that frequency is equals to what? 1 over period. The same thing, period is equals to what? 1 over frequency. Alright, you should know this formula. This formula should be the back of your head. The frequency, the period is 0.02. So we have 1 divided by 0.02, right? So 0.02, by the time you do this very well, you have your answer to be 50 hertz. 50 hertz. 84. Which of the following is a derived unit? Remember I said you know derived unit and you should also know fundamental unit. So Newton is a derived unit. 85. The maximum displacement of a vibrating particle from its equilibrium position is known as the amplitude. So amplitude is the maximum displacement from equilibrium. Please take note of that. Okay. 86. In a DC circuit, the capacitor acts as the insulator or open circuit. All these answers that I am putting in brackets is either you see insulator or you see open circuit. Okay. So in steady DC, a capacitor blocks current after charging. All right, because it's not conducting electricity, so it acts as an insulator in open circuit. Okay. 87. The work done by a machine is 400 joule. Why the energy supplied is 500 joule. The efficiency of the machine is, you should know, efficiency is equals to output over input, right, times 100. And then you know that efficiency of a particular machine can never be 100. The reason why it can never be 100 is because of frequency. So you can see a question like that. It tell you, why is it that machine efficiency cannot be 100? It's because of friction. Because of friction. Take note, it's because of friction. Okay. So output is what you have output to be 400, input to be 500. So by the time you do that, you get 80% as your answer. Okay. 88. Which of the following mirrors always form a virtual erect and diminish image? We have convex mirror. We already talked about it. We have explained the length rule. Other questions we have answered. Okay, 89. The force that opposes the motion of one surface over another is known as friction. So friction resists motion between surfaces in contact. Okay, take note of that. All right. 90. The SI unit of pressure is Pascal. The SI unit of pressure is Pascal. You know, Pascal is force. Sorry, pressure is what? Force over area. Alright, force over area, which makes pressure Newton per meter. Newton per meter. Okay, and that is equivalent to what? Pascal. Okay, Pascal. 91. The spontaneous disintegration of the nucleus of an atom is called radioactivity. Radioactivity. So radioactivity is the natural spontaneous breakdown of unstable nuclei. You should know nuclear fusion, joining together, nuclear fission, separating, okay, destruction. All right, next question. Which of the following instruments is used to detect the presence of a static electric charge? You have your gold leaf electroscope. So a gold leaf electroscope detects and indicates electric charges. You should take note of that. All right. 93. The process by which two light nuclei combine to form a heavy and more stable nuclei is known as nuclear fusion. I said it in the previous question. When they come together, it's known as fusion. When they separate, it's known as what? Fission. So fission combines light nuclei like hydrogen to form heavy nuclei. And what happens? They release energy. So in fusion, they release energy. While in fission, they absorb energy or they use energy. 94. The property of a material that allows it to return to its original shape after the removal of a distorting force is known as elasticity. Okay, so elastic materials regain their original shape after they have been disturbed. 95. Which of the following is used to measure the rate of flow of a liquid? All right, this might be new to some persons, but the answer is venturimeter. Venturimeter is used to measure the flow. It measures the flow rate using pressure differences. Okay. 96. A capacitor of 4 Faraday nanofarad is connected to a 100-volt source. The energy stored in the capacitor is, you know, energy. Now, what connects this capacitor C with this guy volts V? You should know this formula. Energy is equals to half CV square. Half CV square. Okay. So now, when we have this capacitor, we are giving this. Remember that it must be in Faraday. It must be in, sorry, it must be in Farad. It must be in Farad. So for it to be in Farad, we have 4 times 10 raised to the minus 6. Right. So by the time you solve this, put it into this equation. Right, you're going to have 0.02 joule as your answer. Okay, so 97. The color of an opaque object is determined by the color of light that it reflects. All right, color of light that it reflects. Opaque object reflects the color we see and absorb others. Okay, so opaque, we are seeing something from an opaque object, you're seeing a particular color because it's reflecting it. Those ones you are not seeing because it has absorbed those ones. 98. The escape velocity from the Earth's surface is approximately 11.2 kilometer per second. Take note of that. So the standard escape velocity of the Earth is approximately 11.2 kilometer per second. 99. Which of the following parts of the electromagnetic spectrum is used in night vision goggles? We have infrared. Infrared detects heat radiation. So because it detects heat radiation, it enables vision in the dark. So those who have night vision issues, infrared goggles can be used to rectify that. And 100, the last, we have the weight of an object is maximum at the pole of the earth. So it's maximum at the pole of the earth because gravity is slightly stronger at the poles due to the earth's shape and rotation. Alright, so we have come to the end of this video. 100 questions, JAMB 2026 question on physics, and I know you learned a lot from this question. And with this, you are now ready for your 2026 physics examination. Okay, so please do not to check out the video that I dropped for chemistry. Alright, I'm also going to still drop another video for chemistry, another 100 set of questions for chemistry, because the previous one I dropped it before UTME. Okay, and it was just a compilation of possible questions. And here, some of the students testified that they saw those questions. But then I'm going to make another separate video again from the compilation of those who have written in day one and then those who have written in day two and most likely day three. So I'm going to be dropping that video. Okay, so that you don't miss out on all of this, ensure you hit the subscribe button, subscribe to this channel, ensure you share this video to your friends. Okay, this is going to encourage me to drop more videos because when I see that the engagement of this video is doing so well, I will be encouraged to drop more video. Okay, once again, I wish every one of you success in your examination. And as usual, if your physics examination goes well, because I know it will definitely go well, ensure you come back to this video and comment in the section on a particular question you came across and you saw in this video, or how this video helped you to tackle a particular question in your examination. Bye for now, guys.